Hi friends, we're starting with the second lecture of the lecture series on Indian geography, physical Indian geography concepts. Last class we have seen the Earth interior structure, the layers, how Earth has got its layers, and different discontinuities. We remembered them using the mnemonic techniques, and then we saw how we know about the interior of the Earth using seismic waves. There were the two types of waves, the surface waves and the body waves. We saw the basic difference between the P-type and S-type of waves. The difference lies in the way they move around. Okay, so today we are going to start with the theory of plate tectonics. Another two things which you can note down is one was the seismic waves to find out the composition of Earth in the interior parts, and the two other are the first one are the volcanic eruptions because volcanic material also comes to the Earth from great depth. So using and analyzing those volcano or lava or molten rocks, we can find out what is there in the interior of the Earth. And second thing also, the meteors which fall on the Earth. Okay, because we have seen in initial phases of the universe everything was made of the same element. The way of formation was same. So that is how by understanding or analyzing the meteors which falls on the earth, we can also find out the earth interior. So those were the three basic things which we use to understand the earth interior. Now we will start with the theory of plate tectonics. We will see the theory of plate tectonics and then the different boundaries, plate boundaries, and then later we will see the consequence of these plate boundaries results into different phenomena like earthquakes, volcanoes, and mountain building. So let us start with the theory of plate tectonics. The first thing what we can do is to have a look at this world map, the location of different continents, and we can clearly see here like this whole map the different boundaries of the different continents or different landmasses which are not separated by vast distances, but they can fit in a way like a jigsaw puzzle. Like for example, you can see this area of Red Sea which can fix, then this Madagascar which can come to the East Africa, and then whole East Africa can be fit into the India, and then also the Antarctic Ocean. So there are some points which actually led us to the conclusion that yes, there was a movement of plates on the Earth's surface, and we have seen in the last class also there were two types of crust, the oceanic crust and the continental crust. We also saw the very important point that the oceanic crust are the denser made up of denser rocks than of the continental crust. So seeing this map, people long back they started thinking about this, whether it is a mere coincidence, like all this world map can fit together, or in fact this can tell us the wide-ranging features of the development of our of the different continents on our planet Earth. So this was the first point regarding the plate tectonics. The world map fit like a jigsaw puzzle. Then it was observed that in some parts of the Antarctica, huge deposits of coal it was discovered, and discovery of oil was there in the coastal parts of the Antarctica. Now we know that coal is a deposit that comes from the decay of plant or other organic materials. Same is with the petroleum also. This is where the coal and petroleum forms by the decay of organic materials. Then the question comes in the icy expansion, like we know Antarctica, it's all made up of ice only. How there are the depositions of coals and oils? If you consider the present climate, there would be no vegetation which can decay to give such a huge rise of oil and petroleum, and also particularly the lower temperatures, because this deposition will then require higher temperatures to convert into the coal and petroleum. So definitely, we can say that in geological history there was a time when the temperature of whole of Antarctica was quite elevated, and the vegetation and different organic material were there in enough numbers, which would have now led to the rise of the deposition of coal and petroleum. So world map fit in zigzag way, and then coal and oil on Antarctica. Then we can also discuss about the distribution of animals and plant species across the different continents, which are now separated by oceans. Okay, so some species of plants and animals which are confined to a particular region only, but now we have found the fossils of those plants and animal species in some different continents which are separated by altogether oceans. So this also suggests that yes, there was a time when all these land masses were together, and these plants and animal species were there all around. Now the fourth question, which says, is why certain parts of the earth are more earthquake prone. Okay, so these are the 4 points which actually led to the theory of plate tectonics. Now we will ask two questions. We'll start with this question: why certain parts of earth are more earthquake prone, and uh, why or where the young oceanic crust, okay, oceanic crust, we know like what is oceanic crust, so where the young oceanic crust is heading. Actually, it has been found that it was found in the 1950s that the age of the oceanic crust are much younger than the continental crust. Okay, the age of the oceanic crust is much younger if we compare it with the continental crust. Then there's a question which can arise that if oceanic crust is young, okay, then there has to be a place where it is growing. Okay, and if it is growing somewhere, where it is heading to. Okay, so this one point you keep in mind. We'll try to answer this in later section, that where this young ocean crust is heading to, right? And the second question, what we said, like if we draw the regions where the which are the more earthquake prone, like all these regions, if you can see, this is the ring of fire, we know that. Okay, so these all regions are more earthquake prone, while other regions of the world, they are almost earthquake free. So now all these questions, if we club together, now this has to be the points which actually bothers, which started bothering the geologists at that time. Now, if we see the chronology of events, the first name is very important, Alfred Wegener, who actually started giving the explanations about the origin of oceans and continents, and also about the reasons for the cold in Antarctica. Though his reasons were not really up to the mark, and there were many contradictions which happened on the theory which was proposed by the Alfred Wegener. Then we saw in 1950s that the oceanic flows are young and proof of sea flows spreading. So what happens is, suppose there's a big mid-Atlantic ridge. You can see on the atlas also, there's a big mid-Atlantic ridge, which actually gives us the clear example of sea flow spreading. So now if this is the point of spreading of spreading of sea. So the moment now we start going away from it, the moment we start going away from it, we find the rocks becomes more older in nature. So if we start going like this, so we have older rocks, and here we have younger rocks. So I think this is clear. In 1950s, we started getting evidences of sea floor spreading, in which it was found that the strips across the ocean floor, which grows older if we move in a certain direction from a sea feature, and this is the point of center, which from which the younger crust will come up, and then older will go like this. And again, there's another point of the magnetic polarity. It was found that in older rocks and the new rocks, there was a difference in the magnetic polarity. So this also gives reason that they came up on the Earth's surface during different times. And the second point, the precise earthquake location should show predominance of quakes near plate boundaries. So this was the reason, like in Second World War, it was found that all those earthquakes, they are happening around the plate boundaries, and the rest of the world, it is free from the earthquake regions. Now we will see some of the key points which you have to remember about the plate tectonics. Certain key points which you can note down. The first point, if you see the lithosphere, what we have discussed, okay, the lithosphere, which is made up of the crust and the uppermost part of the mantle, which flows over ethnosphere. It is comprised of number of pieces of plates of different size. Okay, so lithosphere, it is comprised of different pieces, or we also call as plates, which are of varying size. Which are of varying size. Now, these plates, they move in relative motion to each other over asthenosphere. So we have seen that in last class also. These plates move with respect to each other over asthenosphere. Alright. Now, why these plates move? These plates move because of the convection current. Convection cell which develops in molten lava. So like this, what we have seen in the atmosphere also, the development of the conventional cells. So these you can see, this is the mantle and the hot lava goes up, then it cools down, then it comes down again. So this leads to the movement of plates on the crust, or the plates in the lithosphere. So this is very simple. Lithosphere, it is made up of different pieces of plates which are of varying size. These plates, they move with respect to each other over asthenosphere, and these moves because of the geothermal energy which is received by the asthenosphere made by the conventional cell in mantle. Okay. Now the second key point, if we see, is something we call as subduction. Now, as we have already pointed out in last class, that oceanic crust, they are much heavier, much denser than the continental crust. So once these two, they come in contact with each other, the oceanic crust will start going down the continental crust, and with the further movement, like suppose if it goes below 100 kilometers, and they will get the temperature again, they will get melted and they will convert it into molten lava, and this is known as the process of subduction. And this possibly also gives the answer to our question what we have stated, that where the spreading sea floor is going, and how young sea floor is consumed underneath the continental crust in the form of molten lava. Now we'll go to the key concept, that is the second or third point which we have to remember in the plate tectonics. Last class we have also seen the difference in the thickness and the sizes of the continental crust and the oceanic crust. So we know that oceanic crusts are thinner. Oceanic plates are thinner. So through these thin layer, the magma comes out and it spreads as a flow. So because of being thinner, the magma comes out and spreads as a layer. So if you keep these things in mind, then everything else is very simple in plate tectonics. Now, these are some of the major and minor plates. There are some major plates like the North American plates, the South American plates, the Pacific plate, the Antarctic plate, the Eurasian plate, the African plate, and the Australian Indian plate. So these are the major plates. There are some minor plates also like the Caucasus plate. You can locate Jufa de Fuca plate. Okay, so like these, there are some minor plates as well, the Philippine plate. Okay, so just have a look at all these plates, which all are the oceanic plates. There is a part of both the continental and the oceanic crust on that particular plate. Just have a look for that, though we need not remember these things. And this is the figure what we have seen, the convection currents which actually drive the plates movement. If they are away, they will go apart from each other. If suppose this convection current is in this direction, then they will start converging, or they will come closer to each other. Now we'll come to the different types of plate boundaries. What happens when two different types of plates come in contact to each other? They go away from each other. First are the divergent plate boundaries. Divergent plate boundaries, as the name suggests, going away from each other. Going away from each other. So these are the two phenomena. What happens? One is a rift valley. When two continental crusts they move away from each other, it gives rise to the rift valley, like what we have in Africa. East African Rift Valley. You can just locate in the map also where this rift valley is located. It happens because of the divergence of the two continental plates. Then we have already seen the phenomena of sea floor spreading, which happens when two oceanic plates they move away from each other. The sea floor spreading. So these are the two basic characteristics of divergent plates which are going away from each other. So this seafloor spreading also we can see this is through this gap the molten lava will come out and it will form a younger crust. Younger crust. And as we will move away from this, we will get the old rocks. Now coming to the second type of the motion between the plate boundaries, they are the convergent plate boundaries. Convergent plate boundaries. This first one you can see it is the ocean and the continental plates convergence. So ocean plate it is going down because of being heavier and denser below the continental crust. Okay, and the perfect example for this, if you want to see on the map also, it is the northwestern coast of North America. Of North America. In this, we see the subduction of the Pacific plate, which is an oceanic plate, under the US plate. So, subduction of Pacific plate under American plate. Now, certain features what we can write is the rock debris because of rubbing action and a zone, a broken rock mass, then this valley will be filled with the sediments and the cracks which are there on the continent will lead to the development of volcanic arcs. Okay, we have seen like as it will go inside, it will get heated and it will again convert it into lava and it will come out to the gaps in the continental plate or the oceanic crust. Key feature you can write is the formation of volcanic chains. Now again if we see the oceanic and oceanic convergence, its perfect example we can give of east coast of Japan, which has led to the formation of the complete Japan archipelago. So this is east coast of Japan. The feature will be same as what we have seen in the case of oceanic and continental convergence, and we see the formation of volcanic islands. Now, when we see the convergence of two continental plates, it will lead. So, like suppose if we give the example, there are two cars which are moving and if they collide, they will fold up. Okay, they will come fold up. So same happens when two continental curves they collide. They lead to the formation of mountain ranges, which we call as a fold mountains. Perfect example which we can give is of the northern Himalayas of India. Northern Himalayas of India, where the Indian plate it is colliding with the Eurasian plate. So Indian plate colliding with Eurasian plate. Eurasian plate. Okay, so this is very very important for Indian history to understand that two continental crusts they are colliding and they led to the formation of big mountain ranges which we call as the fold mountains. Now third one we can see here the transform boundaries. Okay, divergent which are going away from each other, converging which are coming towards each other, and these are the transform boundaries on which one plate will slide with another plate. Transform boundaries. Perfect example what we can give is of the west coast of the southern part of the North America, the California part, where we see the sliding of Pacific plate with the North American plate. So classical example what we can give is west coast of southern part of North America, and it will lead to the earthquakes. And this is something which we call as the fault line. So this is where we can see the transform boundary with the send and west fault. So this is the Pacific plate and this is the North American plate, and they're passing towards, they're sliding against each other. Okay, so this is a figure we can explain different phenomena. So this is the trench. Trench happens, which is the deepest point in the ocean, where the oceanic crust is subducting under the continental plate. Then we see the subduction of the two oceanic plates, leading to the volcanic islands arc. Okay, so and these are the so sea flow spreading, which happens when two oceanic crusts they go away from each other. Okay. Similarly, the very important part for us is the continental and continental plate convergence, which lead to the formation of young fold mountains. Young fold mountains like Himalayas. Right. So now we will move after studying the plate tectonics. We have seen that the Earth was not the same like what it looks today. There was a movement of the plate boundaries, the different plate boundaries of which the lithosphere is made up. So based on the direction of the convection current, it has moved away from each other. Some has merged with each other, which has led to the different phenomena, so the different geological features on the Earth surface. So this is not a very important part, the geological history of Earth completely, but we can remember certain important points. Like initially there was a supercontinent, Pangaea. Okay, around 250 million years ago. So you can see this picture. So these are the rough years, 255 million years ago, 250 million years ago. So this was the continent Pangaea. Then we saw in Triassic period, it got separated into two parts, Laurasia and the Gondwana lands. Then we see Jurassic. So this was like we saw the further movement of plates, and then Cretaceous, the recent one, and then now what we have in present. So another thing to remember is during this division of Pangaea into Laurasia and Gondwana in the Triassic period, India was a part of the Gondwana land. So this question was asked in UPSC once, that India was part of which continent, the Gondwana land or the Laurasia. So India was a part of the Gondwana land in Triassic period when there was a division in the supercontinent Pangaea. Now we will focus on the geological history of India. We'll try to answer certain geographical features on India, the reason for their existence in India. Let us start with, we'll make a flow chart of that, okay? That is going to be the easy one. The first one, if we see, when the India was a part of the Gondwana land, okay, millions of years ago. Our main land was Peninsula Plateau, what we have. So main landmass was Peninsula Plateau. This Peninsula Plateau was made by the three different parts, by merging of three different parts. First were the Aravalli, so they were the Aravalli ranges. There was Dharwad Plateau and the Singhbhum. So there were three boundaries, and this whole peninsula was made after the collision of these three different land masses: Aravalli Ranges, Dharwad Plateau, and Singhbhum Plateau. So because of the collision of these three different land masses, we saw the formation of the different mountains in that age, like the Aravalli Ranges, the Vindhyan Ranges, the Satpura Ranges, the Eastern Ghats, and Bijawal, which is nothing but present-day Chota Nagpur Plateau, which roughly covers the area of whole Jharkhand, Chota Nagpur Plateau. Okay, so one thing what we can deduce here is the Peninsula Plateau is the oldest geographical feature, geological feature on the Indian subcontinent. And these are not Ghats, these are coast, western coast. Okay. So this all happened when India was the part of the Gondwana land. Then India got separated from Gondwana land. Indian plate got separated from Gondwana land. Which is in the period of Mesozoic time. Then we saw the separation of Madagascar island. All right. Now, after the separation of the Madagascar island, this Indian plate it continued moving towards the Eurasian plate, and in between the path, last point was point number 5th. So now this is the 6th point. In this, what happened when India was moving towards the Eurasian plate, the Indian plate was moving towards the Eurasian plate. There was a chain of volcanic islands. We can also say there was a hotspot activity which was happening in that way. So in this way, what happened? It was the deposition of magma. So when Indian plate passed over that chain of volcanic islands or the hotspot activity, it led to the deposition of magma over Deccan Plateau. So it led to the formation of layers and layers of magma, and that is why we have a black regular soil in that particular area. So it led to the black soil, which we'll see when we'll study the soils. What are the uses of black soil, the regular soil, the black soil formation, and the Deccan Plateau. Right. So after this hotspot activity, Indian plate meeting with the hotspot activity, it continued its journey towards Eurasia, and then finally the Indian plate and Eurasian plate collided, and then we saw the formation of young formation of fold mountains, Himalayas, which we saw just now, the collision or the convergence of continental and continental plate, it leads to the formation of fold mountains. Okay, so the formation of fold mountains. And when the Indian plate it collided with the Eurasian plate, the pressure was so much, the energy released was so much that the cracks what we saw, okay, the eighth point, the cracks what we saw which was developed on the western coast of India, it got break and it got submerged below the ocean, and that is how we got tilt on west-east direction. So Peninsula Plateau, it got raised at the western side and it got tilted on east-west direction. So Peninsula Plateau got raised on the western side. Right. So after that, what happened? Himalayas were formed. There were different phases of formation of Himalayas, which we will see. Rivers were produced from the Himalayas, and those rivers, when they brought the depositions with them, it led to the formation of northern plains. Northern plains. By depositions made by Himalayan rivers. Okay, so this is the history in brief of the Indian subcontinent. So this is how we have to remember these points, and we also saw the answers of some very typical geographical features of India, like how we have so much of coal reserves, the coal reserves. Around the Chota Nagpur Plateau, around the Mahanadi and Damodar Valley. Then we saw the answer of the black soil, which we find in the Deccan Plateau. Then formation of fold Himalayas, and then why India is tilted from west to east near the Peninsula Plateau side, and then the formation of northern plains. So we need not remember the years, the period, and all. It is not important for the geological, particularly for the general studies part. It is important for the optional part. So we will finish the geological history now, and then now we will move to the physical geography of India. Throughout the geography classes, and it should be a habit from your side to keep the atlas with you, the world atlas with you, and a book which I have already told, the geography through maps, for the ready reference when you are attending these lectures. Physiographic division of India, if we do, we divide it into four parts. The first one are the northern plains, which we saw in the geological history. The northern mountains, then northern plains, then Peninsula Plateau, and then the islands of the coastal India. So we'll start with the first physiographic division of India, and that is the northern mountains. So this is the division. We have the Himalayas, the northern mountains, then we have Indo-Gangetic Plain, then we have part of the Peninsula Plateau, then we have the coastal plains, the western Ghats and the eastern Ghats, or the western coastal plains and the eastern coastal plains. Now before moving to the Himalayas, let us see the different types of Himalayas, which are the type of mountains what we have. The broad divisions will not go technically in much depth because it is not required for the general studies part. There are two types of mountains basically. One we call as the fold mountains, and second we call as the block mountains. So fold mountains and the black mountains. The first thing what we can straight away write is the fold mountains, they are formed at the convergent boundaries, at convergent boundaries, while the block mountains, they are formed at divergent boundaries, divergent boundaries. So how this will be formed? It will formed by a compressive force which will lead to figure like something this. So there is a compressive force, and the block mountains are formed by tensile forces which will go away. So here you will have formation like this. Okay, so these are formed at the convergent boundaries, the fold mountains. They are also known as the young mountains and the true mountains, while these are not known as the true mountains. The fold mountains, they have extensive mountain ranges with them. These are not the single mountains, they are the ranges of mountains. They have sharp slopes, the great heights, and they are normally formed at the plate boundary. So another features you can write, they are found in form of ranges, found in form of ranges. They have steep slopes, great heights. Okay. Other than Himalayas, there are certain old fold mountains also which are there on the Indian subcontinent, which are the Aravalli and the Eastern Ghats, which we saw, which were formed in the initial phases when there was a collision of three different land masses: the Aravalli, the Dharwad, and the Singhbhum. So, some old fold mountains of Indian subcontinent is the Aravalli and Eastern Ghats. Certain examples of world examples of the fold mountains, if we see which happened because of continental and continental plate conversion, it is first one is the Himalayas, and second one are the Alps, which happened because of the oceanic crust and the continental crust conversion. They are the Rockies and Andes. You can just go to the atlas and you should start locating these mountain ranges in map. Okay, there is no other way to remember them, or we should not be using too much mnemonics. And if you start this habit of going to the atlas again and again, these things will become very clear. So block mountains, we have already seen it, they happen at the divergent boundaries, and particularly with the continental and continental plate boundaries, divergent continental and continental boundaries. The example are the Satpura and the Vindhyas, which make a rift valley, Satpura and Vindhyas, which makes a rift valley, and from which Narmada river flows. We all know this. Narmada river flows from Rift Valley, from this particular Rift Valley. So these are the types of mountains which we normally see, the fold mountains and the block mountains. This is how actually this becomes host, the higher portion, and this becomes carbon. These are the normal fault lines. These are the block mountains which happen because of the tensile forces, while because of the compressive forces we see the formation of the block mountains, the fold mountains. Now we come to the first physiographic feature of India. What we studied was the northern mountains of India. This northern mountains, it is not a single range, but it is a series of four ranges, out of which three are in India and is in Tibet. So four different parallel ranges, one in Tibet and three in India. Three main divisions which are based on the Indian Eurasian plate collision. So when we know that these all mountains were formed because of the collision of Indian and Eurasian plate. So number one, the main Himalayas, which are formed on an actual boundary of collision. So suppose this is the Indian plate and this is the Eurasian plate. and if they collide now, so the mountains which were formed on the SZ boundaries we call as the main Himalayas. And the extent is from the Nanga Parbat in Jammu Kashmir to Namcha Barwa in Tibet. You can see in this figure, this is the Nanga Parbat and this is the Namcha Barwa. Number two, the Trans Himalayas which were formed on the Eurasian side. So these were the main Himalayas which were formed on the boundary. So this is the boundary of the collision of the two plates. So main Himalayas formed on the main border, which were formed on the Eurasian side we call as the Trans Himalayas. And then finally the eastern mountains which were formed on the Indian side. So some eastern mountains which were formed on the Indian side, eastern mountains. Now we will talk about the main Himalayas. Remember the main Himalayas which were formed on the boundary of the Indian Eurasian plate. So it was formed by the collision of two continental plates. We have always seen the Indian plate and the Eurasian plate. These are the youngest and the highest fold mountains of the world. Okay, so we have the marine deposits, which is because of the process known as the geosyncline. We all know that when two plates collide, we also see the folding of the geosyncline valley. So we see the marine deposits. Okay, the marine means ocean deposits which are found on the Himalayas. These are three different parallel ranges. So this is about the main Himalayas. Remember, we have to speak about the Trans Himalayas, then main Himalayas, and then the eastern hills. We are now talking about the main Himalayas. So main Himalayas, three different ranges, highest and youngest fold mountains. We find marine deposits on the Himalayas, and there are three different parallel ranges. Now let us talk about the formation of the Himalayas. Some different stages we will see. So stage one was the oceanic plate of India, oceanic plate of Asia. So suppose now this is the Asian plate or the Eurasian plate, and this was the Indian plate, and this was the Tethys Sea that time. Tethys Sea. So now when Indian plate was moving towards the Asian plate, it was having a part of the oceanic plate as well. So oceanic plate was also there, and the continental plate was also there. So with this we know when oceanic plate it collides or it converges with the continental plate, it subducts under it and it leads to the formation of volcanic mountains. So the first stage of the formation of Himalayas was the formation of the Karakoram range, which was formed because of the convergence of the oceanic plate of India with the continental plate of Asia, which led to the formation of volcanic mountains. So please remember, Karakoram range is a volcanic mountain. Karakoram range is a volcanic mountain. Then second step we saw the continental plate, because this now oceanic plate has already been converged or subducted under the continental plate. Then we have the continental plate of India colliding with the continental plate of Asia, led to the formation of Great Himalayas. Then the second stage we saw again the formation of Middle Himalayas, because the convergence was the pressure was heavy. The formation of Middle Himalayas, which are discontinuous in nature. And then finally we saw the formation of Shivaliks. So there are three layers: the Great Himalayas, the Middle Himalayas, and then last Himalayas we call as the Shivaliks. These Shivaliks were formed because of the raising of deposition which were brought by the Himalayan rivers that time. Okay, so this is the formation of three layers of Himalayas. We have two different divisions of Himalayas, just to for the sake of studying it well. The first one is the north-south division of Himalayas, the north to south division. Then we have west to east division, and there's some regional divisions of Himalayas as well. First, we will talk about the north-south division. The first division is the Great Himalayas or Himadri, which we have seen. They were formed first. Second division, we have Middle Himalayas, or we also call as the Himachal. The third Himalayas, or the Lower Himalayas, or the Shivalik. So these are the three divisions if we do it from north to south. Let us talk in brief about each one of them. The Great Himalayas, which are also known as the Himadri or Bahirgiri in the ancient literature, highest and the most continuous range of the world with an average height of 6,100 meter above sea level. Tallest peaks of the world, and there are many peaks which are above 8,000 meters. Okay, Mount Everest, also known as Sagarmatha in Nepal. So Mount Everest we know is the highest peak of the world, 8848 meters. We need not remember the exact height of these uh, uh, ranges or peaks. Kanchenjunga, the second highest peak of India in Sikkim. Kanchenjunga, this is the second highest peak of India. Okay, this is the second highest peak of the world and the highest peak which is there in the Indian boundary. Okay, this is not the second highest. This is the highest peak of India which is in Sikkim, Kanchenjunga. Then we have Makalu, Mansalu, Choyu, Nanga Parbat, Annapurna, Dhaulagiri, all in Nepal. So one important peak, Kanchenjunga, you have to remember, which is in India. Other than this, all which are above 8,000 meters, the peaks which are above 8,000 meters, which are in Nepal, in Great Himalayas. So these are the different ranges. First, second, and third we have already seen. There are certain peaks which are above 7,000 meters also. First we saw which are above 8,000 meters. Okay, the Mount Everest, which is known as the Sagarmatha. In Nepal. So some peaks which are above 7,000 meters, which is Nanda Devi in Uttarakhand, Kamet in Uttarakhand, and Gurla Mandahata in Tibet. There are certain important passes for the Greater Himalayas. State-wise, we can see the Burzil Pass, Srinagar to Gilgit, Zojila Pass, which is from Srinagar to Leh. Recently, the Srinagar-Zojila Pass has been declared as a national highway, NH1D by the center. So this becomes important. Actually, it has been declared as a national highway. Thangla, which is there in Ladakh, located at an elevation of 5,359 meters above sea level. It is a mountain pass in Ladakh. It is the second highest motorable mountain pass in India after Khardungla. Okay, you don't worry, we will cover this as a part of mnemonics as well. We are not like other institutes. We just give the information and it left to the students how to remember that, because these things are very difficult to remember actually in long term. Now, second state if we come, it is Himachal Pradesh. The first pass is the Barchala Pass, which connects Himachal Pradesh with Leh and Ladakh, situated at an altitude of 4,852 meters. It is on the national highway which is connecting Manali and Leh. Being a high mountain pass, it remains snow covered from November to mid-May. Then we have Shipkila Pass, located at an altitude of more than 4,300 meters above sea level, through the Satluj Gorge. The Shipkila joins Himachal Pradesh with Tibet. It is through this pass that the river Satluj enters India. So Shipkila Pass becomes very important. It is through this pass Satluj enters India from Tibet. The pass, National Highway number 22, is India's third border post for trade with China after Nathula in Sikkim and Lipu Lake in Uttarakhand. It remains snow covered during winter session. So there are three important passes which actually are open for trade with China. First is the Shipkila, then Nathula in Sikkim, and then Lepuka in Uttarakhand. The third pass in the state of Himachal Pradesh, Khardungla, situated at more than 6,000 meters above sea level, highest motorable pass in the country. Very important, Khardungla, it is the highest motorable pass in the country. It joins Leh with the Siachen Glacier, and the road, however, remains closed during the winter season because of its height. Then coming to the different state, Uttaranchal, first pass is the Niti Pass, which is situated at an altitude of this. Niti Pass joins Uttarakhand with Tibet. Okay. Lepu Lake Pass, situated in the Pithoragarh district, it connects Uttarakhand with Tibet. So again, a very important pass, Lepula. The pilgrims for Mansoor Lake, they passes through this pass, the Lepu Lake Pass. This pass is one of the India's important border post for trade with China. Then coming to the final state, the Sikkim, the first pass is the Nathula Pass, is located on the Indo-China border. The pass at this particular height, 4,310 meters, forms part of an offshoot of ancient Silk Road. Nathula is one of the three trading posts between India and China. After 1962, it was again reopened in 2006, the Nathula Pass, to trade with China. Then we have a very important pass, Jalipla Pass. It is situated at an elevation of 4,538 meters above sea level. This pass connects Sikkim with Lhasa. Okay, it passes through the Chumbi Valley. This particular point was there in the news, Chumbi Valley in relations with Burma. It is on the tri-junction of India, China, and Burma. Okay. Now, this was the theory thing. Now we will remember all these things. Okay, we will remember all the past using the mnemonics. Again, how to remember them? To have a picture for them. Otherwise, there is no other option to remember them for long other than the using pictures, using your imaginative powers to remember them. So our first pass in this series is a Burzil Pass, what we discussed for Jammu and Kashmir. It connects Srinagar to Gilgit. Now we will need a image for Burzil. Okay, from Burzil we get a Hindi word Bujdil. ये आदमी बहुत बुज़दिल है. Buzdil means weak-hearted or someone who is a coward. So Burzil Pass, we will have an image of Bujdil, which is weak-hearted or a coward person. Now we have to fix some images. First is Srinagar, then Gilgit. We already have an image of a Girgit, and Jammu and Kashmir we have an image of boat. So we will fix all these. Bujdil people cannot travel on boat with Girgit to go to Srinagar. Okay, it is not the work of the coward people who can travel with such big Girgits to travel on a boat to reach Srinagar. So Bujdil or Burzil Pass, it connects Srinagar to Gilgit, and which is in the state of Jammu and Kashmir. Jammu and Kashmir boat. Bujdil people is the Burzil Pass, and Srinagar to Gilgit. Coming to the second pass, which is Zozila Pass, which connects Srinagar to Leh. From Zozila, from Zo, we get Zoo. Okay, Zozila, Zoo. Zozila, if we take out these words, it becomes Zoo. And Leh, our image will be Lays, the Lays chips. So you're enjoying Lays while boating in Zoo. Okay, so you are enjoying Lays, which become Leh. While boating, again we have a picture of Srinagar and Jammu and Kashmir as well. Srinagar and Jammu and Kashmir. So it connects Srinagar to Leh. Who? Zozila. Zozila is Zoo. Coming to the third pass, which is the Thangla. Or from Thangla we get Thanda. Thangla is Thanda or cold. Thangla is Thanda, which is cold. It is very cold in Jammu and Kashmir because it's all mountains there. It is very cold in Jammu and Kashmir, and boats because it is all mountains there. Jammu and Kashmir, we know it's all hill area, so it's very cold in Jammu and Kashmir. So Thangla is a mountain pass in Jammu and Kashmir. And these all mountain passes, we are talking about the Great Himalayas only. Great Himalayas now we are talking about. When we'll go to the middle Himalayas or the Himachal Himalayas, we will see some different passes. So these all passes we are talking about the Great Himalayas. Another pass now is Barchala, or from Barchala we get Bichara. Okay, ये कितना बिचारा है. It connects Manali to Leh in Himachal Pradesh. So Bichara, that boy, gave Lays to Manali, which is a girl name. Okay, Manali is a girl name. If you have a friend by the name of Manali, you can take that image. But in turn, he got slapped. So you can see this picture where this boy tried to give lace to this girl whose name is Manali. But in turn, that girl slapped that boy. Okay, so Barchala, Bichara, it connects Manali to Leh. Then coming to the next pass, which is Shipkila Pass, or Ship Ki becomes ship. It connects Himachal Pradesh to Tibet. Tibet, we already have a picture of monks. It is a place of monks, Buddhist monks. So our picture for Tibet is monk. So Tibetan monk using HP laptop of ship shape. So Tibet using HP laptop, which is Himachal Pradesh, which is of ship shape. So it connects Himachal Pradesh to Tibet. Okay, Shipkila Pass, important pass. Satluj enters India through this pass. So to enter into India, monks need to ijjat lijjat papad first. So we know already have a picture of Satluj river. Satluj is lijjat papads. So Satluj enters through this pass, the Shipkila Pass. So to enter into India, monks need to eat lijjat papad first. Then we have Khardungla or Khardung, it becomes dung, okay, cow dung. Khardungla. So dung becomes cow dung. Some people says that the lays are made up of cow dung, which is found in Siachen Glacier. It connects Leh to Siachen Glacier. Siachen Glacier. So how we will remember this? Khar dung la. So dung is cow dung, and some people say that the chips which you eat, the Lay's chips, they are made up of cow dung, which is especially found in the Siachen Glacier. Okay. Now coming to the next pass, which is the Niti Pass. It joins Uttarakhand with Tibet. Niti is Niti Niyam. Okay, Niti Niyam is a word in Hindi, Niti Niyam, or the rules and regulations which you should follow, the Niti and Niyams which we should follow. So monks follow all Niti Niyam in temples. So monks is Tibet, and temples we already know it's a picture for us for Uttaranchal or Uttarakhand. So monks follow, you can see this picture, all these monks follow the tight, strict rules and regulations in temple. So Niti Pass, Niti Niyam, it connects Uttarakhand with Tibet. Then we comes to a pass known as Nathula Pass, and our picture for Nathula, if you know that there was a very famous dialogue of Amitabh Bachchan picture that मुझे हो तो नथुलाल जैसी वरना नहीं हो, मुझे हो तो नथुलाल जैसी. So it is in Sikkim, and it connects with China or Tibet or China trade. So Nathulal, Muche or mustache, we will have as a picture of Nathulal ki Muche or Nathula. Kim Sharma really like Muche like Nathulal. Kim Sharma is a picture for Sikkim. Sikkim becomes Kim Sharma. So Kim Sharma really like mustache like Nathulal. And China's people also like to keep such Muche. Whose Muche? The Nathulal Muche. So that is how we'll remember Nathula. Then comes the final pass, which is the Jalip-La Pass. So from Jalip we get Jeep. It passes through Chumbi Valley, or Chumbi is, our picture will be Chumba or kiss. Chumma is a Hindi word for kiss. So Kim Sharma also wanted to kiss R.D. Burman in a Jeep. R.D. Burman is our picture for Burma or Myanmar. And we have seen it is on the tri-junction of China, India and Myanmar. So Jalip-La Jeep, it is in the state of Sikkim. It is the tri-junction between the Myanmar or Burma, China and India. Now we come to the second parallel layer after the Great Himalayas, which is the Middle Himalayas, or we also call as the Himachal Himalayas, which is a discontinuous range. So the first difference between the Great Himalayas and the Middle Himalayas is that the Great Himalayas were the continuous range, while here we see it is a discontinuous range. General elevation is about 3000 meter, which is much lesser than the Great Himalayas. It was, so if we write the difference here, this is a continuous range, and this is, it was average height was about 6000 meters. Some important ranges are Pir Panjal in Kashmir, Dholadhar in Himachal Pradesh, Nag Tibba in Uttaranchal, Masuri in Uttarakhand, and Mahabharat range in Nepal. So these are some of the important ranges in the Middle Himalayas. Pir Panjal, we can get a picture of Pir Fakir, the saints, okay? Pir Fakir. So we know that Kashmir is a hilly region, there are Himalayas, mountains, and Pir Fakir, they like to go to the mountains to worship or to pray. So Pir Panjal is in Kashmir, Dholadhar or Dhuedar Ballebaji, okay, attack batting in Himachal Pradesh or in HP laptop. Nag Tibba in UK or Nag in temple. Masudi again in Uttarakhand, this we know. Mahabharat range in Nepal. So this is how you can remember the different ranges in the Middle Himalayas. The very best known pass in this particular Middle Himalayas, we have seen so many passes which are there in the Great Himalayas. Now this we are talking about the second parallel there, which is the Middle Himalayas. The best known pass is the Pir Panjal Pass on famous Mughal road. This particular Mughal rose was used by the Akbar in 1956 to conquer the Kashmir, and Jahangir also died while returning from Kashmir on this particular range only. P Punjab Railway Tunnel. It is approximately 11-kilometer long railway tunnel, which is the part of Udhampur, Srinagar, and Baramulla rail link project, which is the India's longest railway tunnel, the P Punjab Railway Tunnel. So we can remember this. There is another pass, Banihal Pass, which we also call as the Jawahar Tunnel. It connects the hill areas of Jammu to Kashmir Valley. So Banihal Pass, it connects Jammu to Kashmir, situated at an elevation of 2,835 meter, which is again is in the P Punjab range and joins the Jammu with Srinagar. The pass remains snow covered during the winter season, and the Jawahar Tunnel, named after our Prime Minister, the old Prime Minister Pandit Jawaharlal Nehru, inaugurated in December 1956. Inaugurated in 1956. So this particular Jawahar Tunnel, which connects Jammu to Kashmir, it was opened by Jawaharlal Nehru in 1956. There is no full stop here. This is NH1A National Highway, which connects between Jammu and Srinagar. Now we will start the remaining portion of Himalayas. Then we will see also the mnemonics of Brahmaputra River, which we have left last time, and then we will move further to the northern plains and the peninsular plateau of India to finish the first portion of Indian physical geography, which is about the physiographic regions of India. Thanks for watching.